Hi, you guys. This is going to be a video demonstration for our lesson. The previous lesson was about volume of cylinders, right? And today we're going to talk volume of other circular solids. So, the thing about a cylinder is it's like a prism, except it's got this circular base, right? And to get the volume, we did the area of that base, pi r squared per circle. And then we multiplied it by the height to see, well, how many of those circles areas would fill this, right? So area of the base times the height, right? Well, we're going to talk about the relationship between a cylinder and then a cone and a hemisphere and a sphere, okay? So the thing about these is they have the same base, okay? So the circle that is the base of each of these is the same. So they have the same area of the base, right? And the same height. So this one could go inside of that. So clearly we can't just do area of the base times the height. For this, it's going to be smaller. But they have the same area of the base and they have the same height. So we obviously have to take some fraction of it, right? So the question is, what fraction is it? So how much of this relative to this? So the way we're going to do that, figure it out, is I've got some sugar. I'm going to see, well, how many cones does it take to fill this cylinder that's the same height? Okay. So, I hope I'm making too big of a mess or spilling it on my computer. Okay, so there is one cone here. And if I put it into the cylinder, and I'm going to mark its level right now, it's about here. Okay. So if you make a prediction, what is this amount relative to the cylinder? We're going to keep filling it up until it's all the way full. Okay. So that was one cone full. There's another cone full. It's not quite full yet. And there's 3 conefuls. Okay. So this amount is 1 coneful. It took 3 of them to fill this up. So relative to a cylinder with the same area of the base and the same height, this cone is going to be a third of that volume. So no new formula to memorize. You just are going to do the exact same formula for a cylinder. It's just you're going to take a third of it. So divide it by 3. Okay? Okay, so we know that for a cone now. What is the relationship between this hemisphere and this cylinder? Well, they too have the same area of the base. So this circle base, right, is the same as the cylinder. Now, the height, you'll notice then, is also the same. So before we go further, I want you to think about the height. What are we going to call the height of a hemisphere or a sphere? Okay, well, it's from my thumb to the top there. What measurement is that from here to here? It's the diameter. So the height of a hemisphere and a sphere is its diameter. Okay, and there's lots of diameters in there, right? So let's see again what the relationship is between the volume of a hemisphere and its cylinder that has the same area of the base, same height, diameter. Okay. Now you remember before how I made a little mark on there when I did the cone? So how many of these do you think it's going to take to fill this up? There's a second. And there's the third. Okay. So it took 3 hemispheres to fill this cylinder with the same base and the same height. So again, nothing new to memorize. It's going to be a third for a hemisphere. Well, what are we going to do then if we want to do 2 hemispheres or a full sphere? Well, we're just going to double it when we're done, right? Okay, So hopefully that will help kind of get that visual will help you memorize these new formulas. We're going to take some notes on this now.